Alright, so now we're moving on to 19.2. Here's our essential question. What can you conclude about the angles of a quadrilateral inscribed in a circle? Lucky for you, our lessons are easy again, but first there's gonna be a lot of vocabulary words, right? So, there you go. First of all, you have to know what inscribed means, right? Inscribed means it's inside, okay? So this right here, you see this quadrilateral. Quadrilateral means a shape with four sides, right? So let me write that down for you. Shape with four sides. So this quadrilateral is inscribed in a circle. So inscribed means it's inside a circle. And here's another thing, important thing. It's inside a circle, but it's not like, here's like a four-shaped thing inside a circle like that. The four corners, okay, the corners, all corners, or vertices are touching the edge of the circle, okay? So that's a really important definition. When you say inscribed quadrilaterals, that means the shape is inside the circle, and look, all four vertices, 1, 2, 3, 4, are actually touching the circle, okay? So it could be any kind as long as it is, touching the circle. All right, so then after that, we're going to move on, and I want you to look at something like this. For example, look at this circle right here, right? If you look at this angle E, okay, so yesterday we learned about this right here. So we have this angle, and so that is what we call an, I think it was an inscribed angle, right? Yes, it was. And so then how big is this angle? Well, we don't know yet, but we know that that would be the measure of all of this stuff, right? But then now let's take a look at this angle right here. This angle. Okay, so this angle, this red angle over here. So what is the size of this angle? Well, we don't know for sure, but what do we really do know is that that would be half of that angle, okay? So this angle over here would be half of the red arc, and then this black angle right there, this black angle would be half of this arc. Hey, what did you just notice? If you add the red part and the black part together, that's the whole circle. So that's how many degrees? Yep, you're absolutely right. That's 360 degrees. But we're talking about inscribed angles. So yesterday we talked about inscribed angles. So how big is this angle plus that angle going to be? That's gonna be half, right? So it's 180 degrees, okay? So what you need to learn by looking at these inscribed quadrilaterals is that opposite angles are supplementary, okay? Supplementary meaning they add up to be 180 degrees. So that angle and that angle add up to be 180. Same thing, this angle and this angle add up to be 180 degrees. And of course, I didn't just make it up. It's called an inscribed quadrilateral theorem, right? So that's pretty much what I just told you. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So angle A, and I can't see the letter here, but those two angles will add up to be 180, and then angle D and angle B, they would add up to be 180 degrees. All right? So that's basically it. All this other stuff that you have to do, and please watch this video. Mr. Berger is awesome. Okay? Burglar! So now, let's move on. Here's a really awesome question that you have to know, right? It says, find the measures of each angle in the inscribed quadrilateral JKLM. Ooh, so there's 1, 2, 3, 4 angles. Obviously, this quadrilateral is inscribed inside the circle, right? And they gave you the 4 angles. Well, not this one, but they gave you this angle, which is 9x minus 11 degrees, this angle, which is 12x over 2 degrees, and this angle, which is 5x plus 51 degrees, right? So remember what we just talked about? Yes. So we know that this angle and this angle add up to be 180 degrees. I'm obviously not picking this one and this one because this question didn't give me how big that angle is, okay? So let's go ahead and set it up. 9x minus 11 plus 5x plus 51, they add up to be 180 degrees, right? So let's combine like terms. 9x plus 5x is going to give you 14x. And then we have negative 11 plus 51. And that's going to give us positive 40. And that equals 180. From here, it's too easy. We gotta leave the x all by itself. So we're gonna go ahead and subtract 40 from both sides, right? And so 14x is equal to 140. We still have to leave the x by itself, so we're going to divide both sides by 14, so x is equal to 10. Yay! What we have to remember, and a lot of you get this part wrong on the test, is the question did not ask what x is equal to. So you can't stop here. What is the question asking? It says, find the measure of each angle. So that means you gotta find the measure of angle J, K, L, and M. Alright, so let's do it. What that means is you gotta plug in the x into each of the angles, okay? So I'm gonna use a different color for that. Measure of angle J is going to be what? 9 times 10 minus 11, which gives me 90 minus 11, and that gives me 79 degrees. Now let's take a look at measure of angle K. And so 12 divided by 2 is 6, and 6 times x is 10, so that's 60 degrees. That was too easy, so I just did it in my head. I'm sorry if you needed to see the work. Now let's take a look at measure of angle L, and you gotta plug in the 10 into the x, so 5 times 10 plus 51 gives you 50 plus 51, which is 101 degrees. Now we're just left with the measure of angle M. I'm going to have to erase this side because I ran out of space. So let's do this. This angle and this angle are supplementary. So the measure of angle M, capital M, plus the measure of angle K is supposed to equal 180. We already know how big measure of angle K is right here. That's 60 degrees. So let's do this. Measure of angle M plus 60 degrees is equal to 180 degrees. So what do you think the measure of angle M will be? Well, let's subtract 60 degrees from both sides, and that gives me measure of angle M equals 120 degrees. And so there you go. That is the last part of my answer, right? Measure of angle M equals 120 degrees. So your answer would be all of this. Measure of angle J is 79, K is 60, L is 101, and M is 120. And we are done. Please make sure that you understand this, okay? So then, of course, I would like you to obviously work on your turn question on your own. It's the exact same kind of question with obviously different letters. So it tells you gotta find the measure of every single angle. You cannot stop after finding what Z is equal to, right? So that's something for you to work on from your online textbook. And there you go. We have 19.2. So over here, they show you how to draw an inscribed square. So I want you to think about something, right? First, you have to draw a circle, have a center, and then you draw a radius. And then you have to use the compass to draw a perpendicular bisector. Then you connect them. And bam, you have a square. And then at the bottom, it tries to help you prove why that is a square. And you know what? The best way to learn that is by watching Mr. Berger's video. But let me go ahead and try to explain that to you really fast over here. So when you were constructing this, you already knew that these were perpendicular lines because that's what you constructed here. You drew a diameter, a line, a segment for a diameter, and then you drew another segment and that was the perpendicular bisector. So you already know that all these four angles are 90 degrees, right? And then this, that, and this, and that all measure the same because what are they? They are the radii in the triangle, right? The radius is going to be the same no matter where it is, right? So all these sides measure the same and all four angles measure the same. So what that means is, if you are just looking at this triangle, okay, this triangle and that triangle and this triangle and this triangle are all congruent triangles because of what? Because of the SAS, congruence postulate. And we know this because what? These two measure the same and this angle measure the same for every single triangle. So that's the side. There's four pairs of side, four pairs of angles, and four pairs of side that measure the same in each of these triangles, right? And so then, since all four triangles measure the same, we can come to the conclusion that this side, that side, and that side, and that side all measure the same, right? And so what was the definition of a square? Well, the four sides are congruent. They all measure the same. And another thing is that all four corners or all four angles are congruent as well. Well, are right angles, which means they're 90 degrees. So right now, I just proved to you that four sides are congruent to each other, right? So now let's go ahead and see why the four angles measure the same, okay? For that one, we have to think about the inscribed quadrilateral theorem, right? So there you go. Here's this angle right here. And look, this went through, this is 180 degrees, obviously, because that's half the circle, right? So what's 180 divided by 2 since this is an inscribed angle? Yeah, that's 90 degrees. And it's going to be the same thing for all the other corners. Look, here's this side right here. This is going to be 90 degrees. Why? Because look, this is half a circle, which is 180 degrees for that arc. So if you want to find the measure of this inscribed angle, you got to divide by 2, and so that's also 90 degrees. And the same thing happens for this side and that side. And so now I have just proved to you that all four angles measure the same, and they're all 90 degrees, and all four sides measure the same. Okay? So now let's move on to the your turn question here, which is very silly because obviously this is the only one that is a square. So now let's go into your evaluate questions so you know which questions you have to study for the assessment. I would say number 17, 17, 14, and then 7 through 12. Let's see, what about 8, 9? Yeah. So number 7 through 12, let me write this down. In the evaluate section, it will be number 7 through 12, and then number 14 and 17. So please work on these questions in the evaluate section so you'll be prepared for the coming assessments. I will see you tomorrow. Happy learning.